expression for equivalent capacitance in series. Let us derive the expression for equivalent capacitance in series. Okay, it is very important for 3 marks. Expression for equivalent capacitance in series. Let us consider the capacitor. First of all, we know that capacitors are said to be in series when we are connecting end to end. We are giving end to end connection, then we can say that the capacitors are in series. Okay, let us draw the diagram first. I will consider two capacitors which are connected end to end. Here the charges are plus, minus, plus, minus, minus q, plus q, minus q. Okay, C1 and C2. Here the potential difference V1 for C1 and V2 for C2. For whole, I will consider this one as V, equivalent to plus, minus. Here I draw two capacitors, two potential. I took two potentials V1 and V2, but here I will consider it as equivalent capacitance. So I took potential difference as V, or V is equal to V1 plus V2. Okay, now we can write the explanation for the diagram. Explanation for the diagram as, let us consider two capacitors of capacitance C1 and C2 which are connected in series. Let V1 and V2 be the potential difference across C1 and C2. Then V is the potential difference across this combination. Q is the charge on each capacitor. In series combination, we can write, okay, series combination, from the figure only we can write that. What we can write? The potential difference across the combination is equal to potential difference across capacitance C1 and potential difference across capacitance C2. I will write potential difference across the combination is equal to potential difference across C1 plus potential difference across C2. So we can write potential difference across the combination. From the diagram we can write, from in the combination potential difference is V is equal to potential difference across C1. Potential difference across C1 is V1 plus potential difference across C2. Potential difference across C2 is V2. Now I will consider this equation as equation 1. Now from the definition of capacitance, we know that C is equal to Q by V. I will rearrange this equation for Q. That is, Q is equal to C into V. Okay, in equation 1 we have V is equal to V1 plus V2. So we want the expression for V. We can rearrange this equation for V also. So V is equal to Q by C. Then V1 is equal to, we have charge as Q only, so Q, and we have capacitance, two capacitance C1 and C2. For V1 potential difference I will take capacitance as C1, and for V2 we can write V2 is equal to Q by C2. Now what we can do, we can substitute V1 and V2 value in equation 1. Equation 1 becomes V is equal to, V1 value is Q by C1 plus V2 value is Q by C2. Here now Q is common, so I'll take Q outside. V is equal to Q into 1 by C1 plus 1 by C2. Okay. Now for V1 we had Q by C1, and for V2 we had Q by C2. For whole combination, that is, we have to derive the expression for capacitance in series. So for whole combination, that is, V is equal to Q by, what happens to the capacitance for whole combination means C1, C2, C3, like that. Capacitance in series, we have to take capacitance in series. So for whole combination I will write V is equal to Q by Cs. Now what we can do, we can substitute this expression here. So V becomes Q by Cs, which is equal to same Q into 1 by C1 plus 1 by C2. Next, what we can do, here Q get cancelled, remaining is 1 by Cs is equal to 1 by C1 plus 1 by C2. Now if here there are two capacitors, so I wrote 1 by Cs is equal to 1 by C1 plus 1 by C2. If in case there are n number of capacitors, what happens? 1 by Cs is equal to 1 by C1 plus 1 by C2 goes on up to 1 by Cn, which is the expression for equivalent capacitance in series. Thank you.